I thought I'd do something a little bit different today. So over on Instagram at TrevTutorOfficial, I've been posting some logic games every couple days, and I figure every 5 or so, I'm going to make a video guide with solutions because these logic games are used on things like the LSAT and they help with other sorts of reasoning and logic and mathematics. So these range in difficulty from really easy to medium difficulty. Maybe I'll do some harder ones in the future, but let's take a look at the first 5 that have gone up between September 27th and October 9th, 2021. So the first one is the very first puzzle I put up, which is definitely the easiest one here. So we have a code consists of 4 digits from 1, 2, 3, 4. I'm just going to write all the information that I need here and show you the process. So we know there's an order to it, so we can put 4 little lines there. A number cannot be used twice, so this means that we're going to be using all 1, 2, 3, and 4. The second digit is half of the fourth digit. So let's think about this. If the second digit is half of the fourth digit, then this means that the last 2 digits cannot be 3 or 1 because we don't have a 1.5 or a 0.5. So the possible combinations here are either we're going to have 1 in the second digit and 2 as the fourth digit, or we're going to have 2 as the second digit and 4 as the fourth digit. It will be one of those two combinations. So this will take care of that second point. 3 must appear before 2. Okay, so I mean, this really means that 3 can appear in any of the positions because 2 can be in that last place. So our last thing says 2 cannot appear as the last digit. Okay, so this rules 2 out of position 4, which rules, of course, well, where can 2 go now? This means that we can't have the 1-2 combination for the second and fourth digit. So 2 and 4 have to be placed as the second and fourth digit. 3 must appear before 2. So these 3 are canceled out, which means 3 has to be the first digit, and our only remaining digit is going to be 1. So the code is going to be 3, 2, 1, 4. Okay, so this was by far the easiest of the puzzles that I've made. So let's take a look at one more difficult. And if you want to try these now and you haven't been following me on Instagram to see these, of course, pause the video, try it yourself, and then walk through the solution. Okay, this question is different because we're not asking for a code. We're just asking for what must be true, essentially. So a library carries at least one of the following books, A, B, C, D, E. So this is like an in or out problem. There are going to be things that are carried and things that are not carried. So we have some rules here. If C is not carried, then E and D are carried. So we could think of this sort of like conditional logic. If not C, then we have E and D. Okay. If A is carried, then we have B and C are being carried. If D is carried, then we know A is carried. And we're also told that B is not carried. Now, what's our question? Is which books must the library carry? So what has to be in our library? Okay, so we're going to start with this piece of information here that we don't have B. So let's just put A, B, C, D, and E at the bottom, and we're going to say, okay, B is definitely not in. Okay, so to solve this, we need to make use of something called the contrapositive. And for any conditional statement, what you can do is you can negate both sides, flip the order, and that's called the contrapositive. So for instance, if we have D arrow A, this is the same thing as saying not A, arrow, not D. So the second one says if we don't have B and C, then we don't have A. And this is going to say if we don't have both E and D, then we're going to get not C, which is the same thing as saying it carries C. So this information is going to help us solve the rest of the puzzle. So we know that we don't have B. So we cannot ever satisfy this condition, or sorry, like the original condition. So we don't have B and C. This means that we don't have A. So we don't have B, so therefore we're not going to have A, so we can cross that out of our list. Now, if we don't have A, we we know the contrapositive of rule 3 tells us then that we do not have D. So we're not going to have D in our system. Then, if we don't have D, as shown in the contrapositive of our first rule, this means that we're definitely going to have C. So what does this say about E? Well, it doesn't necessarily say anything about E. It could be in or it could be out. We are not sure. But the question just asks which books must the library carry, and the answer is just C. It only needs to carry C, but it could carry E. That would not affect any of the rules here, whether it's in or out. So just by having a few conditionals and one statement, we were able to solve the problem. Okay, that one was definitely more challenging than the first and tested some conditional reasoning. The third puzzle is another order race. So very similar to the first problem, except instead of 4 things, we have 5 things, and the situation's a little bit different. So we have 5 kids racing, A, B, C, D, and E. We could give them full names, but I mean, it's an Instagram post. I can't write full names. It's too many words on the picture. There are no ties. So obviously 1, 2, 3, and 4. If we want to write the place numbers, we can. I just usually order left to right, 1, 2, 3, 4, 5. Okay, there are no ties. So that means that A, B, C, D, and E are going to be in different positions. Let's just forget about that, mark that off. C does not come first. So there's 2 ways we can annotate this. We could say C is not first and put a line through it, or we could say, well, C can be in one of these 4 positions. Okay. I prefer this way because I can see what all the options are for C. There are 2 people between B and E. So this is interesting. So this means that in our thing, we either have to have B space E, or it doesn't tell us the order. So E space B. So what does this mean for placements? Well, I don't want to put them into the grid right now, but this really means that we can never have B or E in the center position. So if we want, we can sort of just annotate that that cannot be B or E for sure. Okay, D placed immediately after A. So this means that we're going to have A and then we're going to have D side by side. So I might annotate it like that. If you watch LSAT books or read those, you'll see them put a box around it. I don't like the box. It muddies up my little field of notes. So I usually just put them side by side. And E did not come first, second, or third. So this means that E is going to be in one of the last 2 positions. Actually, I'm going to get rid of this. Why? Because based on rule 3 here, if E is in one of the last 2 spots, and B and E have to be at least 2 spaces away, this means that B is either going to be in the second spot, or B is going to be in the first spot. So it's either going to connect like that, or connect like that. Okay, so with these rules now written down, we should be able to solve this entire puzzle. You might ask, how can we possibly solve it with just this information? Well, this is where our reasoning skills have to come in. So let's think about this. Really, we just need to know that it's B blank blank E at this point, so I'm going to clean up the field a little bit more. And the question really comes down to, where can we put AD? Because these have to be side by side. And if we know anything about how B and E are placed, in fact, let's just sketch this out. Sometimes it helps to sketch out 2 different situations. There's a situation where we have B and E in those 2 positions, and there's a situation where we have B and E in these 2 positions. Both of these would be acceptable at this point. No matter what we do, we have to put A and D in between B and E, otherwise they just won't fit side by side. Which means that the last person, C, either has to come in first or last. But we had a rule that said that C cannot come in first. So this means that the only acceptable order is going to be B, A, D, E, C. So this one was a little bit different from the first problem because you had to create two hypothetical situations to see where these things could go and then rule one out afterwards. We couldn't really just look at this line of B, B, C, 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 E, E in our little green lines and figure it out from there. Okay, two more. Here we're getting a little bit more complicated because we don't have an, any information about the order that something is definitely in. So we know there's 6 professors now, so we're amping up our numbers, P, Q, R, S, T, and U. So 1, 2, 3, 4, 5, 6. And we're given some rules. P arrived before R and T. So to do this, I'm going to use a little bit different of a notation. So P arrived before R and T, so just so I know what my order is, I'm going to put first here and sixth here, just so I know that the left is people arriving first. So P arrived before R and T, so I'm going to say P is before R and P is before T. I'm going to use this line notation. So that takes care of rule number 1. T arrived after U, but before S. So this means compared to T, relative to T, U came before T, but T arrived before S. So this means that T is earlier in the ordering than S. Okay, S arrived after R. So now this grid's getting a little bit more complicated. So R is before S. And R did not arrive fifth. So this is interesting because we can't really put this into the diagram. We have to put this into the order top. And Q arrived earlier than U. So we'll put Q here. Okay, so we have a little diagram of orderings, and we know that R did not come fifth. Now, the question is not asking us for a total order like the other ones did. That's what makes this different. It gives us a hypothetical, and it says, if Q arrived second, so if Q is here, what is the earliest and latest that R could have arrived? So our focus is on R. And because it says earliest and latest, I imagine we're going to have to construct a couple different scenarios to figure this out. And I say I imagine, but that's how I designed it. So, if Q arrives second, what can happen? Well, let's think about this. We know that U, T, and S for sure are going to come after Q, so somewhere later. So our question is, what can come before Q? Well, R can't come before Q because R has to come after P. Okay, so that's not going to work either. The only thing that we can put in front of Q is going to be P. So P has to be first. So we're done with this one, we're done with this one. Now, we have to order U, T, S, and R. But what we do know is that U, T, and S have to be not necessarily side by side, but they have to be in that order where U is in front of T and T is in front of S. We also know that R has to be ahead of S. But we don't know R in relation to T and we don't know R in relation to U. So really, what we have now is that R could come before U or R could come before T, but R, well, we're going to see a problem if we try to put R like right after S here. So let's think about this. Can R ever come sixth? Can R ever be in this position? In sixth place? The answer to that is no, because it has to come before S, which means if R was in last place, S would be outside of our 1 to 6 people. We know that R cannot come fifth, because it's in the rules. So can we have a situation where we have R fourth? Well, if we have R fourth, our only requirements now is that we have to have U, T, S in order, and S has to be after R. So we could do U, R, T, S. That would be fine. Okay, what about third? Okay, so we can say that fourth is definitely the latest. But can R come third? Well, let's think about this one. If R is third, We just know that it has to come before S. So yeah, we could do R, U, T, and S, and this would also be fine. So the earliest that R is able to come is third. And we know it can't come second or first because if Q is second, then Q occupies that second position. And if Q is second, that means P has to be first because that's the only place that P could actually appear. So a little bit tougher. All of these get progressively tougher. And I believe conceptualizing this fifth one might be the most challenging, but in terms of execution, it's not actually that bad. So in this problem, we have 6 professionals, P, Q, R, S, T, and U. And we know that 3 are musicians, so 3M, and 3 are artists. Okay, so this is interesting because we're aligning our letters into specific categories with a set number of people. So let's just go through the rules, and if we find some information that would change things, we'll make some alterations to the setup, but this is just the base information we have from the problem. The first one, R is an artist. This is great. I'm going to say that R is equal to A, and what I'm going to do to help maybe is make a box with A and a box with M, just to see where we're fitting things in. Okay, so I'll put R in here. Now we know there's 3 positions for each, so maybe I'll put 3 underlines here. Okay, T is a different profession than S. So I'm just going to put something like T is not the same as S. I might annotate this as being TS or ST and put like a little box around them so we know it's one of these two. Okay, if S is a musician, then so is Q. So if S is M, that means that Q is M, and I'm going to subscript these just to save some notation so that way there's not a bunch of equal signs everywhere. In fact, now that I'm thinking about it, I might want to go back and say R equals A might be confusing, so I might just want to write RA. That way the T naught equals to S can mean what we want it to mean. Okay, if P is an artist, then so is U. So if PA, then UA. The first 3 award receivers are musicians. Oh, this is interesting. So now we have an order in here. So let's put that information down. 1, 2, 3, 4, 5, 6. And we say that the first 3 are musicians. So M is up here and A is down here. We know that R is an artist, so R is somewhere in this space. We don't know if order matters yet, but hey, we have some order information, so let's use it. Okay, the last rule says either Q received the last award. So if Q receives the last award, that means Q is going to be an artist. Or P and T are both not musicians. So basically, if P is not a musician, that means T is an artist, and T is not a musician, that means that T is an artist. So we have all of our information here. It's quite a bit. And the question is, well, where do we start with this? Okay, well, let's think about this or statement because I think we're going to have the most use with this final statement about Q receiving the last award or P and T both not being musicians. So if P is an artist and T is an artist, let's entertain this first. This would mean that our artists are going to be R, P, and T. But if we think about rule number 4, if P is an artist, then U is an artist, that means that U would also have to be in this category as well because P is an artist. But that would mean that we have 4 artists, and that's not allowed. So we know that this second statement here, PA and TA, cannot be true. So this means that Q is definitely an artist. Okay, so R and Q are artists. Now, what can we use from this information? I mean, this clue is completely done. And there's a lot of stuff going on here, so let's just cross that out completely. Right, R is an artist, let's get rid of that completely, and the first 3 award receivers are musicians. Okay. So, We could do some hypotheticals, or what we see is information about Q being a musician. And if we remember conditional reasoning, this means if not QM, then not SM. But if Q is not a musician, that means that Q is an artist. And S not being a musician means that S is an artist. So if Q is an artist, S is an artist. That is what this third rule is telling us. So we know then that S is going to be an artist, which means we know who our artists are. So the musicians should be everyone else. And we know that S is not the same thing as T. So if S is an artist, then T must be a musician. And if P is an artist, then U is an artist. But U is not an artist, clearly, because there's not enough spaces left. So U must be a musician, which means that P has to be a musician. So we know who the artists and musicians are, but the question asks who are the musicians, which means we could have, well, we had to solve the whole thing to get that. The musicians are going to be T, U, and P. Okay, that's it for this video. If you enjoy this kind of stuff, go over to instagram.com/TrebTutorOfficial. Follow me there. You'll get 2 or 3 problems a week, and then I'll put up a video every 5 problems or so going through these. This is both preparation for the LSAT for me, the logic game section, and also I just really enjoy these types of puzzles, so I figured, what better way to really understand how these puzzles work and to solve them than to make them yourself and try to make them interesting and throw in different types of rules and different puzzles. Because if you know how to create something, you know how to deconstruct something. So if you have any questions, you can put them down below, and I'll do my best to answer them.